We don't have those 3 zeros yet. Now, I want the student to read from that handout to sort of give us an idea of how to approach this. By the way, before I jump into and show you some methods on something like this, which looks crazy right now, does anyone have an idea of what X could be and would work? I can quickly plug it in, substitute it in, and see if it works. Okay, if not, let's go through what the kid did in middle school. Now, your handout gives a name for what he did. He had no clue. He was actually using something called a theorem. And it's on that handout. Guys, can someone find the part, maybe in the back there somewhere, rational zeros theorem? Okay, I need a student to read that to me, and I'll show you how it applies here. It's called rational zeros theorem. I'll take a little effort here. This now, if I have a student read to me the word rational. When the student finally reads to me, it's going to look much like what the kid in middle school did. But when the student reads to me the statement on your handout, rational zeros theorem, this does not include irrational numbers. So if one of the 3 zeros has a square root in it, this will not work. This will not give me a notion of what's happening here. So no irrationals. This is only for rational. Imaginary? No imaginaries. It's going to just give me possibilities of rational zeros. Now, could I have a student read that statement to me? We're pre-calc SMC. This is not pre-calc high school. So I need a student to read that to me. We'll make some sense of that. The statement sounds crazy. The wording may throw you off, but let's make some sense of it. Who would like to read? I need a volunteer. Billy, read for us.
It says, let f be a polynomial function of degree 1 or higher of the form f of x equals a. How do you say the n on the bottom?
Yeah, a subscript. Subscript n.
Subscript n x to the power of n plus a subscript n minus 1 x to the power of n minus 1.
Now we know what's going to happen here. We had that on the board earlier. Billy, just to interrupt you just a second, I'm going to write this and get this part out of the way. Actually, they're saying the function looks like that. Is that true? That's what we said at the beginning of class. That's what it looks like.
There's a little more afterward.
Oh yeah, I didn't know there's going to be more, but that statement right there is okay. Now read more.
It says where each coefficient is an integer.
Okay, they want each one of these coefficients to be an integer, no fractions. Okay, tell me more.
It says if p over q in lowest terms is a rational zero of f, then p must be a factor of a subscript 0, and q must be a factor of a subscript n.
That's what the kid did. Eventually he did it. He's going to list all the factors of that constant term on the end first. And they're saying in that rational zeros theorem that she's is reading for us, that goes on top. They call that the P. And guys, look at this. That's my constant term. That's my a subscript 0 in this problem. I've got to list all the factors of 40. I give you a fairly large number to work with. I've got to list all the factors of 40. And there's quite a few. Now I'm going to write like this to save me a little time. Plus and minus 1, plus and minus 40. You multiply those two together in some shape there, you get 40. 2 and 20. Plus and minus 2, plus and minus 20. Am I leaving anything out? 8 and 5. Plus and minus 8, plus minus 5. At this point, is that it? Are those the only factors of 40 you can think of? Now, consider the plus and the minus. Are we okay? Or is there something else out there? Tell me again, 4 and 10. Plus minus 4, plus minus 10. Is that it? For 40? I think that's it. Now, she's read to us. She says, Professor, now this Q here, and by the way, look at this, guys, this is a fraction, isn't it? P over Q? And that's what they're saying, a fraction is like a ratio. And that's why they call this the rational zeros theorem. We're forming fractions, we're forming ratios. And they have written as P over Q, numerator over denominator. Now I got to list all the factors of, Billy I think said now, list all the factors of that leading coefficient. I think it's A subscript n, right?
Yeah.
And not too many think it's for 3, but those go down here. Factors of 3 plus minus 1 plus minus 3. Now, I would never ask a student, not on a lengthy problem like this, to now take what you see in front of you and list all the possibilities of these 3 zeros we're looking for. What are the possibilities, candidates? List them, and then we gotta go through and find the 3. And we're hoping all 3 are among those that we're gonna list. Guys, anyone tell me on the side here? This over this. Can anyone give me now a number that I might want to test based on what you see right now? Replace the numerator over the denominator. Now I'll get you started. You may say, Professor, I can put positive 1 over positive 1, right? That's a ratio, that's a fraction. And that would give me, of course, 1. I could place, Professor, a positive 1 over a negative 1. That's a negative 1. That's another possibility. Then move down to 40. 40 looks horrible. 40 over 1, that's 40. 40 over a negative 1 would be a negative 40. Is that true? 2 over 1, I'm not going to list all of them, we'll slow down here a second. 2 over 1, 2 over a negative 1. Let's try, oh my goodness, 20. Here goes, get some large numbers here. 20 over 1. Oh, by the way, did I finish all that up? 2 over 1, 2 over a negative 1. Was it 2 over 3 also? Help me out. And negative 2 over 3. I may have left those out by doing all this. Oh, by the way, is that 40? I left out some of the 40 also. Could I say 40 over 3? Did I fix that up? And what? Negative 40 over 3? I've got to keep myself organized here. Now I stopped at, right here, I'm 20. You do the same thing as 20. You do the same thing here. Do the same thing here, 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 here. And you keep listing. This could be a task just to list the possibilities. You see how many possibilities I have right now? And I'm not finished. Because that's the rational zeros theorem says first list those. Well, I've listed so many of those. And then choose one that you think might work. Now, many students will do this. They'll say, Professor, my goodness, I'm tired, Professor. I'm going to test 1. If it works, we've lucked out. I think 1 is one of these, Professor. I think 1 is one of these 3 zeros you're looking for. There's this possibility here. Guys, here we go. I'm going to test 1. Now, how have we been testing? How did the kid back in middle school test? You go through and plug in all those x's with what? A 1. That is so time consuming. I'm going to show you a shorter way to do it. So on the side here, we're going to test first 1. To do it without direct substitution, I'm going to block off 1. That's my test number. Watch carefully. Some students may have seen this when I set it up. This just saves us a little time. No direct substitution now. Then go back and look at all my coefficients right here. and my constant, and list those coefficients just a little bit above here. And you have this, 3, -13, -18, -40. And then draw a line here, I'll show you what to do here. Make sure all my numbers are correct. Beautiful.
I think positive 40.
But
Positive.
did I leave something out?
Positive.
Oh, down here. Okay, 40, positive. Now, do we have all those now? Now watch carefully. Mathematicians have done this. I'm sure I appreciate mathematicians. Rather than directly substituting, which is going to take a little time, they now call this synthetic substitution. Synthetic substitution. Mathematician made to save me from direct substitution. They call it now synthetic. What am I going to do? I'm going to start testing numbers. I'm testing 1. Now watch carefully what you do to test. You're going to get used to the process. You start out with placing a 0 underneath the first number always. Now you add those numbers up in that first column. 3 plus 0, not exciting, it's 3. Next, you take this times this, a little process, 1 times 3, tells you what goes underneath the second number. So that's 3, and that goes here. Put it in blue. That blue will work for me. And we'll put that here. Guys, if I add them up at this point, I think you end up with a -10. Right here. Next, this outside test number times -10 will tell you what goes underneath the third. 1 times a -10 is a -10, and that goes here. Add them up. Do not let me make a mistake. Right here on top of the board, is that -28? I think. And what's my last possibility? Is that 1 times a -28? Yes or no?
Yes.
That goes here. This is called synthetic. And add them up on the end, and I end up with a number, yes, a number, it looks like it's 12, is it? Woo! What do you think I was hoping I would end up with on the end? 0. That means the number you tested is not one of the answers you're looking for. Didn't work. He said, Professor, I'm getting frustrated. I'm getting frustrated. You will get frustrated at first. Because right now, I just know we're supposed to have 3 zeros, and I've tested 1, and 1 does not work. So 1 is out, will not work, cannot use it. Then you may say, Professor, what now? Well, test -1. If that doesn't work, test 40. Now, usually those large numbers, in most cases, will not work. That 40 and -40, I doubt seriously if they are a 0. 2 might work. That's a smaller number. -2 may work. I haven't tested these yet. 2/3, fractions may work. May work there. And then all the others, and I did not list all the possibilities, did I? No. Jeez. Right now, we're stuck. We do not at this point have any of the zeros. We're expecting 3. I know for sure right now 1 is not one of the 3 zeros. Does anyone have a number that you might give me that's coming from this, that you like, and I'll test it?
40.
Now, the larger numbers usually don't work. Who said 40? I can test 40. Usually the larger numbers are just a little too large to work out, will not give me a 0 on the end. I don't think it's going to work.
-2.
To begin.
-2.
-2, hang on. So guys, that's done. Now, suggestion. Professor, go through the synthetic substitution, and this time try -2. Yes, that's a possibility. Here we go, same process. 3 negative 13, negative 18, and on the end there, positive 40, I guess. Now we're hoping, with his help, that this one works. Here goes. A 0 underneath the first one, always. Add them up, get a 3. I'm going to show you something here that may help us shortly. Next, negative 2 times 3, that's a part of the process, that's a negative 6. That goes underneath the second number. Add them up, I think it's a negative 19. Right here. Guys, product, negative 2 on the outside. Negative 2 times a negative 19 is what? Positive 38. That goes here. Add those up, I think it's 20, is it? And the outside number times negative 20, this times this, tells me what goes underneath that last number is that negative 40. And that goes here. And with his help, we've just discovered one of the 3 zeros. He asked me to test what was a negative 2, and we tested. So right now, I have negative 2. I still have 2 more to find. I'm enjoying this. I don't know about you. I'm enjoying this. Now, does anyone have another favorite that you think will work so we'll find a second 0 of these remaining possibilities? And I'll test it.
5.
I heard 5. I won't test 5. 5 would be among those. Certainly would be among those. Now, since he's already given me one that works, I do not, after I find that one that works, I do not have to go back necessarily to the original coefficients. I may stack these. In other words, I can test 5 on these remaining numbers here. Where am I? 5 over here. On these remaining numbers. So as soon as you find one to work, you need not go back to the original 3, negative 13, negative 18, 40. No, you use the remaining numbers left there. And he's asked me to try a 5. I'm hoping 5 works. Here we go. I'll do it quickly. 0. Add them up. 3. 5 times 3, 15. Add them up. What's that? Negative 4. What's 5 times a negative 4? Negative 20. Woo. Alex? Was that Alex who gave that to me?
Yeah.
Thank you. 5 works. We just discovered another 0. I need one more. And since we have all these stacked up, you may test down here only now. You don't have to go back to the original. Just use those numbers. Because you want to have one that might work. And I'll test it in those remaining numbers down there, and that's what it works. And I'll give you a hint. I think this one's going to be a fraction. And I have some fractions listed. And there could be more. Because you want to have an idea, when I start listing all these possibilities, of a fraction that maybe you'll say, Professor, test this fraction. That's a possibility.
Negative
Do it again.
negative 2/3.
Okay, hang on, we'll test it. That's hope. Here we go. Negative 2/3. Right here. We've got 0, 3. Guys, negative 2/3 times 3, is that negative 2? I think 3's cancel. Does that give you a negative 2? And if you add those up, what do you get? Is that a negative 6 down here on the end of the board? I was hoping to get a 0. Did I get a 0? No, that's a good, not quite. So negative 2/3 did not work.
Would be 4/3.
Tell me again.
4/3.
Positive 4/3 or negative?
Positive.
Hold on. Now run out of space down here, guys. Bear with me. 4/3. Put right here. Here goes. 0, 3. Multiply those two together. I think 3's cancel and gives you a what? 4. Look at that. Did I get 0? Who gave me the 4/3? Nice. Here we go. Now, do I have all 3 zeros? Took a little time, but I got finally all 3. Now, right now at this point, the issue would be, especially on test night, quiz night, that would be next Wednesday for this material. Alexandra sitting there may be having a good night, and she does one of these problems, and she picks one of the zeros that works, one of the numbers that does work, it's a 0. She picks it just immediately. She's having a good night. Absolutely. When I play blackjack in Vegas, sometimes I have a good night. I played blackjack in Vegas. Won $10,000 one time. Yeah, it all depends. You may say, Professor, try that number. You try it, it works. Others, Alexandra may say, all of a sudden, you see her going out the door and say, you finished? Oh yeah. I tried one that works, and with that I found the others, the remaining ones, I found all of them. Now all of a sudden I turn around, the other 34 students are still here. They haven't found one yet to work. That's the issue. Big issue. Now let me give you a little hint on what you can do in certain cases. First, let me make sure I got everything correct here. Guys, I think, did I test 1 earlier? I did, didn't I? And it did not work. We got a what? 12? Here's what it means. It didn't work though, but here's what it means. It means when X was 1, you got a 12 to come out. It didn't work, but that's what it means. Alexandra, Ignacio, class, a little benefit, even though it didn't work, a little benefit is if you should be asked to find P of, where is it back here? P of 1. Suppose you were asked to find P of 1 back here. Most students, and me included, when I was a student, you said, Professor, you should maybe replace these x's by 1 and calculate. That'd be 3 subtract 13, that's a negative 10, isn't it? And then negative 10 minus 18 was that negative 28. Then negative 28 plus 40 on the end is what? Oh, it's 12. Therefore, you need not substitute x with that number any longer. You can do it by synthetic. Just go ahead and find what that remainder, they call it a remainder. Whatever that remainder is on the end, that's it. You've already done the substitution by synthetic. To solve it though, you're hoping for a 0. But there is a benefit here. Also, we're going to graph these, not tonight. Ooh. Maybe I could throw in a graph here. But anyway, I'd like to see maybe, I'd like to see maybe a graph of this later on. We have all 3 zeros, don't we? I may want to see a graph and see what this graph looks like. You know what I am? I want to see what a graph of that function looks like. I already have 3 zeros. Guess what that tells me? That tells me not only 1, 12, that this is also a point on your graph. So when I graph it, I'm guaranteed that out 1 up 12 is going to be on the shape of that graph when I finally graph it. Okay, so there's just a little benefit there. What's going on here? Guys, by the way, we have all 3 zeros. Now, hang on. Got something else to tell you. I got a clever class here. We're bragging on you. That's why these professors want you for Math 7. If I find out you're not doing well in Math 7, I'll find you. I'll find you. I know these professors. I'll walk right into class. You're going to say, Professor, what are you doing here? I'm checking on you. Checking on you. I heard that you had your first quiz. I heard it wasn't too good. No. Guys, this one right here, let's go back to this. How many zeros am I expecting altogether? 3. We got all 3. Look at this, here's another benefit. As soon as you find one to work, I don't care which one you find first to work. I tested -2, did it work? That means of those 3 zeros, I found one, which will now drop that cubic down to a what? A quadratic. Are there 2 zeros now remaining? And if there's 2 zeros, that in my mind means quadratic. And guess what the benefit is? After you find one to work, these remaining numbers, look at this, guys, tells you the coefficients and the constant of that quadratic. So you could have stopped there and not done any additional testing and said, wait, professor, as soon as I find one to work, I find one to work first. You're telling me that 3 negative 1920 means this? 3x squared subtract 19x plus 20. Yes or no? That means that. Now, could you solve that if you recognized that those numbers meant that? Could you now solve this and not do additional testing? Could you solve it by quadratic formula or factoring? I think of factors. Here goes. 3x, x. Someone good factoring here. I see a -5 here maybe. A -4 here. Check my factoring. Is that correct?
Yes.
Of course it is. Split this up. Solve each one. Ah, are you kidding? Without additional testing. Are you going to be aware of all this next Wednesday? Mm-mm. Isn't that cute? That is really cute. Now suppose, Alexandra, since you're right here in front of me here, suppose you said, I didn't catch it early, professor, like you did, I got 0 here. So I got 0 down here. Guess what it means down here if you just wait a little bit? Now you found what? 2 answers. You found both these to work. Now let's jump down to a what? A linear. It was a cubic. You expected 3 answers, then drop down to a quadratic. Now these represent what? A linear. Now what would that 3 and -4 represent right here if I should write it out? Thank you. 3x subtract 4 is equal to 0. Solve for x. What do you end up with? Trying to show you guys a few little tricks of the trade here, so you would not have to sit there and start testing every number of the possibilities. That would take forever. So be aware of the things like that might happen here. Guys, we got the 3 zeros. All the thing I want to do now with those 3 zeros, I've used some little tricks there. Here goes. I'm going to graph this. Oh, yes, I'm going to graph it. Here we go. Now, I think I started class out with at 5 o'clock. I think and for the quiz Wednesday, what was it, 3.1? Guys, I think I started out, did I not list the zeros for you? I'm back to the way I started class. I have the zeros listed. Is it true? Now, can someone help me out and write the function that those 3 zeros came from? You say, Professor, it's right there in front of you. This is the function that those 3 zeros belong to. You went through all that business, you found them. The synthetic substitution, rational zeros theorem, is that true? But can someone now tell me in factored form, what does my function look like? P of x is equal to x plus 2. Any more? X subtract 5. Now be very careful. The last one. 3x minus 4, I think I heard. Is that in factored form? If you set each one of those factors equal to 0 and solve, you get those 3 zeros we have. Now, I understood to be a coefficient of 1 out front. I did not give you any additional information on this one. It's a 1. I like to graph this. I'm going to get a quick graph of, and it's going to be a graph of this. Except I put it in this form here. Guys, the graph is going to look like, I better do a good job since we're closing down here. I heard you guys were telling other professors this is your favorite class. Are you guys talking about this class? I think I heard someone say that. Professor said, "Oh, Professor Ramsey, they really are enjoying your class." Are they? Are they really? Yeah, they're enjoying your class, Professor. Absolutely. Let's see if they are enjoying this tonight. Because this is going to take a little time. You guys will see what the graph may look like. Now this ties in somewhat with what I did last week with you guys. Zeros. I've got -2. I will mark it right here. It's an x-intercept. I have 5. X. Here. There. And also I got 4/3, that's 4/3, 1 1/3. That's right in here. 4/3. Those are my x-intercepts. Let me go and find the y-intercept. Can I find the y-intercept, guys? Replace all the x's by what?
0.
0, and you end up with a number of what? 40. That y-intercept's way up there. It's up here. It's up here. X-axis, y-axis, we have all that. Label these. Now, who can recall from last week? What were we doing to graph a polynomial function? I have the zeros, I have the y-intercept. Tell me more.
Sign analysis.
We use sign analysis. I think also we're doing something else that was a little bit quicker. Sign analysis would work definitely. Does anyone recall anything we were doing that was a little bit quicker to get the graph? Ah, beautiful. Now, we say parent graph, that all depends on this first term. That's going to determine what's going on. And by the way, guys, I see an x cubed. Do you see an x cubed? So just a basic x cubed graph. I know there's a 3 there. With that parent graph he mentioned, would that look something like this that we've seen before? So what does that tell me about my graph I'm looking for?
The end behavior.
That's it. Thank you. The end behavior out here on the end. I notice on the end here for the cubic graph it does that. So out here on the end, should mine be doing the same thing? So I'm going to try a different marker so it holds up. Are we saying out here it should be doing this? Just like the blue one. Out on the other end, is it dropping? Should be dropping like the blue one? Down here on this end, are we saying it should look something like that? There's the start on the graph of this. Now I've got more. Oh boy. Now you could use sign analysis. Or. Let me see if I'm ready for it. Yeah, I'm ready for it. I'm going to go from left to right, start connecting. My graph's going up like this. Is it going to cross at -2 and go up, eventually pick up this 40, which it should?
Yep.
So it looks like it's going to cross here. Let me make it a little better. Because it's going to come up, pick up this, and make it a little higher, then come back and pick it up. Who knows? You guys agree with that? It's got to pick up that y-intercept. It's got to come back down because it's got to pick up 4/3. Do you think it's going to cross over again? If it crosses over again, that means it goes underneath. How far underneath it goes, I don't know, you don't know, but it's gotta come back and connect. Just to make it a little bit better here, maybe, more like that. Let me step back, that's a rough sketch of this. That's a rough sketch of what it looks like. Now, you step back, can you guys in the back see that red? Compare it to the blue, the parent graph, and the end behavior. So I'm going to jot down the end behavior right quickly before I forget. The end behavior. What's my graph doing on the end? I'm going to use the calc notation. I'm going to find the limit. We're using abbreviation, limit. As you make x get large, what is my p of x function? What's it doing? Guys, my p of x function is the red one. What's it doing out here on the end? Is it approaching infinity? Is it rising? On the other end, written like this in calculus, find the limit as x is approaching negative infinity. You're on the other end. You're over here. And my red graph, what's it doing over here on this end?
Negative.
Dropping down forever, described as in calculus, negative infinity. That's the end behavior of my graph. The graph's done. Whew. Now, let me throw in something before we close down tonight. I think we've done a good job tonight. How would I know for sure, especially right here, how would I know? Someone give me an idea. The graph's done. How would I know that the graph, the red graph, did not do this when I hit 4/3? How do I know maybe it didn't do this? And connect like that. Wonder why might I say, as you guys said, Professor, I think cross is over. I think it goes underneath. I don't think it's going to bounce back. But I need some discussion. Does anyone have an idea why it may not bounce back like that and it should go underneath as we said it should? Any ideas? Shane?
Multiplicity of the zeros.
Here it goes. It's going to be on a handout for you here shortly. You look at the multiplicities. In other words, guys, I have this in factored form. On the outside of each one of these factors are all of my exponents understood to be a 1. If they're all odd, if they are odd, you will cross the x-axis at those x-intercepts. And mine in this case were all odd, so my graph should be crossing here, it did, cross here, it did, and cross here. It crosses the x-axis if they are odd. I don't have one on the board tonight yet for an even, but you sort of can guess. If this were even, this would do what? It would bounce back. It would stay on top and not cross over. So if it's an even exponent, it's going to touch. Odd exponent, it's going to cross over. Let me step back and look at it. Is it good? Very good. Gee. Okay. Hang on just a second. What else should I do here? Got the graph of this. Can you imagine? This is it. This is the function, and there's its graph. That's its picture, along with the parent graph. Help me out here. You guys any concerns here? Questions? Now, there's no concerns as you sit down and start trying some of the homework, or trying some of the items maybe on the worksheet. Then that's where you might get frustrated. Don't get too frustrated. Because I've done some of these as a student where I tested and tested and tested. It was very difficult to find one to work. Yeah.
Will we have to graph a function for the quiz?
Not the quiz Wednesday.
Just
The quiz Wednesday is more like what I started class out with, where I list the zeros for you. And I tell you the graph may pass through this point, and you just write the function out for me.
Okay.
Something like that. But look in your textbook at 3.1. Okay. So 2.8, 3.1. I think this is further into the textbook. How's that look? We did a lot of work tonight. A lot of work. Now, I've got to, hang on. We got a good start. Oh boy. Yeah, here we go. I'll make it one more sketch in. We're going to sketch, okay? I'm going to give the next one like this, with a little practice to sketch. Guys on the board here, just throw it on the board, save a little time. It looks like this. P of x is equal to this. Looks like that. And I want to sketch the graph of it. Let's see what that graph looks like for that function. By the way, notice the function is in factored form, which is what we want. Okay. Can a student tell me what would you do first?
Find the x.
Find the zeros. Easily done. In fact, you just look at this one, tell me the x-intercepts are zeros. They are what, 2? So let me mess up here. So there's one of the zeros, x-intercept. -3. And we're right there. Another x-intercept. 5. Extend this out just a little. Go out to 5. Another x-intercept. Those are my intercepts. I have the x-intercepts. Let's find the y-intercept. I'll need that. In other words, the y-intercept, you know how to find it. You know, sort of close down with this. You need p of 0. Replace all the x's by 0. You'll end up with this. So you guys agree? Are those the numbers you would end up with replacing x by 0? All the others will be a positive, big number. Positive, what, 90? Gee, that graph is way up here. Is that the y-intercept? Okay. Now, without sign analysis, even though I love sign analysis, let's graph it from left to right. But first, I notice where is it here? On this. Yeah, I get you in factored form. Can anyone tell me what the parent graph on this one would be? A parent graph of what? The last one had x cubed, which sort of guided me. Okay, what parent graph am I looking at for this one? X to the 4th. It's the first term. I'm not quite sure to multiply all that mess out. Would the first term be x to the 4th? Now, does anyone know what an x to the 4th graph, not x cubed, an x to the 4th graph looks like? Just a basic graph. X to the 4th, I have no clue. What does an x to the 4th graph look like? X cubed, you guys know that for sure. An x to the 4th, any ideas? By the way, would 0, 0 be on the graph of that function?
Yes.
Yes, it's on there. Would 1, 1 be on there? Yes or no?
Yes.
Yes. Would -1, 1 be on there? Yes. Would 2, 16 be on there? Yes. Would -2, 16 be on there? So out 2, up 16, out -2, up 16. Connecting my points, it sort of looks like a what? A parabola. Not quite, but it takes that shape. Is that true? Not a true parabola, but it takes that shape, parabolic, they call it. Now, what does that tell me about my graph? On the ends, what should my graph be doing on the ends here? It should be doing the same thing this one was. And this one was. And what was it doing on both ends? Increasing, rising, positive infinity, rising through positive infinity. It's the way Professor, at least you know the end behavior. It's doing like that graph over there. It's doing this. It's doing this. That's true? Now we're gonna get this graph done fairly quickly here. Now, let's look at that. When does it cross and when does it touch? My factors have these exponents. My first factor, which gave me a 2, has an outside exponent of 1. Is 1 odd or even? If it's odd, that means when you reach that 2, which is right here, it should do what? It should cross. So this is a cross if it's odd. Save a little bit of time here. My next factor was x plus 3 squared, which gave me this. If it's an even exponent on the outside, 2, 4, 6, 8, whatever, this says it's going to only touch the x-axis, not cross. The next one has another odd on the outside. So it's going to cross again. That's a big benefit. Now let's go from left to right. At -3, based on this, it should do what? Touch. Should touch. In other words, bounce back, not cross. And eventually it's got to come up and pick up, and maybe do something like that. Pick up that y-intercept. It's going to come on down and pick up my 2. Now at 2, which came from here, what should it do there? Cross over. How far down it drops, guys? I don't know. We don't know right now. Let's go cross over and come back and connect. There. And there's a rough sketch of the graph. Does that make sense? When it crosses, when it touches, in behavior, there's the graph. Jeez. Isn't that nice? Wow. Well, chapter 3, I think I've done half of it already. Take a close look. Any concerns here? Any questions? No. Okay. Now, you're saying, Professor, do you really go to Vegas and gamble? Or are you just saying that? Do you really get those blackjack tables and hope to win some money? I do. I do. Won $10,000, which I felt good back in the day when I won $10,000. I thought, oh, wow. And they had my picture on the wall. Oh, hotel there? Oh, wow. And then I still remember winning the $10,000, and I was doing my little thing right at the end of my stay. So I had my bag with me. I was going back to the airport to fly back home. So I had my bag with me, but I thought, you know what? I've already played blackjack. That was good. I think I'll play one of the slot machines. I got a little time before I have to go back to the airport. So before I leave, I had my bag with me, ready to go home. And I thought, well, I'll drop a few coins. These days, a few dollars. Into the machine. Who knows? What may happen? Well, I dropped it in, something did happen. Let's see, how much did I win that day? Another 10,000, another 6, I think it was, on the slot machine. So when this thing went off, I didn't know what was going on. I saw all these different lights. I thought, it's broken. I broke the machine. No, all these lights going off. Wow, I just stood there like what? And when somebody standing next to us said, sir, I said, you were so lucky. I said, well, I broke the machine. He said, no, you didn't break the machine. All those different colors. And pretty soon the attendants started rushing to me. They said, congratulations, sir. I said, wow, how much did I win? I didn't know how much I won.